In this section, we'll review the Perform Quality Control process. Quality control is monitoring specific project results to confirm they comply with quality standards. They're usually performed by a quality control group or department. Important terms to know are prevention, which is keeping errors out of the process, inspection, which is keeping errors out of the hands of the customer, attribute sampling, where the result conforms or it does not, special causes, which are unusual events, common causes, which are normal process variations, also known as random causes, tolerances, which are acceptable results if they're within a range specified, and control limits, where the process is in control if the results fall within the control limits. Information required to perform this process include the quality management plan, quality metrics, quality checklists, organizational process assets, work performance information, approved change requests, and deliverables. All of those topics should be familiar to you, so we're going to move on to the tools and techniques of this process. Tools and techniques include cause and effect diagrams, control charts, flow charting, histograms, Pareto charts, run charts, scatter diagrams, statistical sampling, inspection, and defect repair review. This is an example of a quality control chart. As you can see, there are 3 bars. The first one at the top represents the upper control limit. The one at the bottom represents the lower control limit. And in the center is the X with the bar over it, meaning that it's the center line which provides the average of the process data. Points outside the upper or lower control limits indicate that a process is out of control or unstable. A Pareto chart relates to Pareto's law that states that a relatively small number of causes will produce a large majority of the problems. You may also know this as the 80-20 rule. This would be a typical way to depict the Pareto diagram. What this chart tells you is that most of the defects are found in the single sign-on functionality. The various areas with their defects are added to this bar chart from the largest to the smallest. This allows the project manager to determine what areas to focus on first. Just to give you a few numbers to figure out how this was calculated, single sign-on was addressed at 290 defects. Debit page had 245, credit page 210, transfers page 190, and add accounts page 160. The total number of defects is 1,095, of which single sign-on had 26%, debit page had 22.7%, credit page had 19.1%, etc. So these are plotted as bar charts on the diagram, and you can see how it goes from the largest to the smallest. The run chart is used to demonstrate the variations of a process or its trends. Make sure the terms reviewed earlier are known as they relate to this tool. Common causes of variances are the result of unique circumstances of a particular process. They're easily controlled, and if not rectified, may cause special cause variances. The scatter diagram displays the relationship between 2 elements as points on a graph. One variable is independent, which is the input, and the other is the dependent, the output variable. As the value of the independent variable is changed, the value of the output may also be different. These 2 variables are plotted on a graph and reviewed to identify trends in cause and effect. The key item to take away from this diagram is to understand that the closer the values are between the dependent and the independent variables, the closer the relationship between them. This concludes the section on the tools and techniques for quality control. In the next section, we'll continue with additional tools and techniques.